All right, this is a good question I received via email. Don't be afraid to put any question up here. There are no silly questions. And yeah, you may remember once I show you where the 2AB came from in this one, but I will have you know I had a guy employed as a maths teacher come to me after his lesson one day and say he didn't understand why all the kids were getting this wrong because he couldn't see where's that 2AB come from. They were his exact words to me. He said, Chewy, where's that 2AB come from? I can't figure it out. He was a pommy guy. So, there are no silly questions. Sometimes we have mind blank. Sometimes we just forget. Let's have a look and see where it comes from. I think the 2AB we're referring to is this plus 2AB or this minus 2AB here. So if I have A plus B all squared, A plus B all squared, when you square something, that means you multiply it by itself, don't you? A plus B times A plus B. Now, what law are we going to use here? We are going to use our distributive law that we even talked about today, so that's very good. This A is going to multiply each term in the second bracket, and then the B from the first bracket is going to multiply each term in the second bracket. So I'm going to go A times A, and then A times B to get AB. B times A, well that's also AB. It's always nice to write your letters alphabetically. You don't have to, but it's just nice. And B times B is obviously B squared. And you can see now where it comes from. This becomes A squared plus 2AB plus B squared. If I was to do the same thing with a minus sign here, all it's going to change, and I'll just do it very quickly here, if that was a minus A minus B all squared, this would be A minus B times A minus B. A times A would still be A squared. A times negative B would be negative AB. Negative B times A would be negative AB. And negative B times negative B, two negatives multiplied together give you a positive. So it would still be positive B squared. So the only change in the rule you will notice from the A plus B and the A minus B, when we're squaring them, the square of a sum and the square of a difference, the only change is this plus 2AB changes to a minus 2AB. When would you ever use this? Well, a nice easy example of where you might want to use this. Let's say you have 103 squared. You're sitting there doing your paper one and you've got to square 103 for some reason. You don't want to write it all out. If you think about this as 100 plus 3 all squared, your life becomes a lot easier, doesn't it? It's 100 squared plus 2 times 100 times 3 plus 3 squared. And you can actually do that in your head. It's not going to be very hard. What's that? 10,000. That's enough zeros. Plus 2 3s are 6 times 100 is 600. Plus 9. 10,609. So you can use this for that sort of thing. We also use it when we're expanding lots of other things when we do binomial probability, which is probability where there are two outcomes, a success or a failure. We're going to use that expansion again. So get comfortable with it. Remember those. Your other one, your favourite rule in maths, the difference of two squares. Why is there no AB term in that one? Let's have a look. Seeing as though it is going to be your favourite rule in maths if it's not already, A plus B times A minus B. When I expand the bracket, I get A times A is A squared. A times negative B, negative AB. B times A is positive AB. And B times negative B is negative B squared. You can see negative AB, positive AB cancel out. So you've just got A squared minus B squared. Your favourite rule in maths, the difference of two squares. I hope that helps. Keep the questions coming. Don't be afraid to put them here in the collaboration space. If you have that question, probably 20 other people do as well. Ask away. Keep up the good work. Great to see everyone doing some maths and asking questions. See you guys.